The second part of this model covers health risks from chemicals in drinking water. There are many non-communicable diseases risks, including arsenicosis and fluorosis associated with chemicals in drinking water. In this part of the model, we will spotlight two emerging risks associated with manufacturing. Micro and nanoplastics. These are tiny pieces of plastic debris that are often invisible to the naked eye. They can be manufactured or formed from breakdown of larger items due to weathering, UV radiation, and mechanical action. Manufactured plastics represent the primary pathway, and breaking down of larger items represents the secondary pathway. These are pervasive pollutants in water bodies that can bioaccumulate over time. There are presently three key entry points into the environment. Direct release, in which plastics such as microbeads in personal care products, microfibers from synthetic clothing, and pre-production plastic pellets can be released directly into water bodies through wastewater effluent runoff or industrial discharge. Larger plastic items such as bottles, bags, and packaging can break down or degrade into smaller fragments over time due to exposure to sunlight, heat, and mechanical stress. And lastly, microplastics can also be transported through the atmosphere and deposited onto land and water surfaces, particularly in urban areas and regions with high levels of plastic pollution. While the health effects of microplastics on humans are not yet fully understood and require further research, there is growing concern about the potential risks associated with human exposure to microplastics through four key pathways. Injection of contaminated food and water. Studies have shown that microplastics have been found in various food items, including seafood, drinking water, and salt, raising concerns about potential human exposure. Inhalation, particularly in urban environments with high levels of airborne microplastic pollution. Once inhaled, microplastics could potentially accumulate in the respiratory system and cause respiratory health issues. Contamination, in which chemicals in the environment are adsorbed, including persistent organic pollutants, POPs, and heavy metals. And physical damage, where the physical presence of microplastics in the gastrointestinal tract can cause abrasions, inflammation, and other adverse effects on the digestive system. Per and polyfluoroalkyl substances, popularly called PFAS, is the collective name for a large group of fluorinated compounds which are used in a wide range of applications such as aerosol propellants, solvents, pesticides, anti-foaming agents, surface treatment for textiles, leather, masonry and paper and board, leveling agents in paints, coatings and waxes, plastics, lubricants and greases, and firefighting foams. The key concerns: persistence. PFAS are highly persistent in the environment and can remain unchanged for long periods. They do not easily break down in soil, water, or air, leading to widespread distribution and accumulation in the environment. Bioaccumulation. PFAS can bioaccumulate in living organisms, including humans, through exposure to contaminated air, water, soil, and food. Once absorbed, PFAS can accumulate in various tissues and organs, leading to potential health risks over time. PFAS have been associated with various adverse health effects, such as reduced birth weight, thyroid hormone disruption, and impaired immune function. Exposure pathway are through widespread uses of the chemicals, but drinking water is one of the several environmental sources of human exposure to PFAS, along with exposure via food, use in consumer products, and occupational exposures. Active review of PFAS is still ongoing.